Hello everyone. Today what we're going to be studying is what causes the path of projectiles to be curved. That's our essential question for today. So first of all, what we're going to do is we're going to take a look at the properties of gravity, and we're also going to look at properties of projectiles, what they are, some of the different characteristics that they have, how they fly in the air, and what causes a projectile to be a projectile in the first place. So what I want you to do while you are watching this video, I want you to record your notes in your notebooks on the input side, just like we've been doing before. The only difference here this time is, instead of you just seeing the PowerPoint presentation and trying to hear me from the back of the room, you are going to listen to me as I talk through the PowerPoint, and hopefully this helps. Okay, so let's get started. Our question for today: what causes the path of projectiles to be curved? Well, let's investigate and find out. Okay, so let's look at this. Gravity. Gravity, by definition, is when any two masses that exert an attractive force on each other. Any two masses that exert attractive force on each other. So that's really a vague thing, isn't it? Gravity exists between objects with mass, period. For example, there is gravity that exists between you right now and the chair you're sitting on, because a chair has mass and you have mass. There's an attractive force between the two of you. Another thing that you could say is anytime you have two objects that are close to each other because of distance and they have mass, there is a certain amount of gravity between them. That's where this statement comes in. Gravity depends on the mass and the distance between objects. So I know we've all heard that the reason why the moon stays in orbit around Earth and the reason why Earth stays in orbit around the sun is because of gravity, right? It's because of gravity. So the reason why the force of gravity has a certain amount to it or magnitude to it depends on how much mass each object has and also how far apart each object is. All right, that moves us to our next topic: weight. Weight is something different than mass. Weight is a gravitational force exerted on an object, and it's measured in units called newtons. Because, guys, it's a gravitational force right here. It's a force. That's why it's measured in newtons. Okay? Now, the greater the object's mass, the stronger the gravitational force or weight on it. Now that is true. That is true. See how the mass affects the weight of an object, but they're two different things. Another example would be if you were to stand on a scale and want to know what your mass is. We call it weight, but we want to know what our mass is really. We would step on the scale and it would read maybe 120 pounds, right? If we were to convert that into SI units, into kilograms for mass, that would be, let's see here, probably just off the top of my head, that would be about maybe 65 kilograms, somewhere around there. All right, so that would be the mass. To find the weight, what we would need to do is we would need to multiply it by the acceleration due to gravity to get that gravitational force, and that would be in newtons. Okay? Next topic, we're looking at projectile motion. So let's look at this. A projectile. I'm sure you've heard of somebody having, this is gross, but somebody having projectile vomit, right? That's nasty. But look at this. It's anything that is thrown or shot through the air, okay? So you throw a paper wad at somebody, that is a projectile. If you shoot a water pistol in the air, the water that's coming out of there is going through the air, that is a projectile. All right? Now, in order for us to understand projectiles, we need to know a little bit about them. A projectile follows a curved path and has both horizontal motion and vertical motion. To define each of these, horizontal motion, according to our perspective, is any motion of an object that's parallel to Earth's surface. And vertical motion is motion that moves up and down or perpendicular to the Earth's surface. Okay, let's look over here at our guy here. He's juggling these bowling pins, and we see as each bowling pin leaves his hand, it's going up, but look at that curved path that it takes. Okay, that curved path is a direct result of both the horizontal and vertical motion. Okay, so as the bowling pin goes up, it's going up, it's going up, it's going up, it's slowing down as it's going up. Well, what's causing it to slow down? Well, there's gravity pulling on it. There's gravity pulling it closer to the ground. So it's still moving to the right. It's moving horizontal, but it's also moving up and down. All right, so the bowling pin goes up, it slows down in the upward direction. Okay, still going up, then it begins to move downward. But as it's moving downward, it's still going to the right too. All right, so that's our projectile. It's still going up, then it moves down as it still moves to the right. Okay, that is, that's a projectile. We're going to be doing a little lab with this, with footballs, which somebody in your group is going to throw a football, somebody will kick a football, and somebody else will throw footballs in different ways in your group. So pay attention to this. This is really important. You're going to be drawing the pathway of the football as it goes in the air. Okay, that's projectile motion. Our next thing that we're taking a look at today is centripetal force. Now, centripetal force, that's the force that keeps you in your seat if you're riding on a roller coaster that has a loop in it that goes upside down. Okay, I hope you've all had the chance to experience that at least once. It's really cool. Also, it's that force, like this guy right here, he's twirling, I don't know if it's a ball or if it's a rock, around his head. What's keeping that object moving in a circular pattern is centripetal motion. All right, we have two definitions that go with this. There is centripetal acceleration, which is defined as the acceleration that's toward the center of a curved or circular path. So we can say that this ball or rock, because it's moving in a circle around this guy's head, has a centripetal acceleration. Okay? And the word centripetal means it moves toward the center. It's moving toward the center. The acceleration is pointed or directed toward the center. Okay? Next one is centripetal force. Centripetal force is any force that's acting toward the center of a curved or circular path. Now, so often we hear words that are different than this, like the word centrifugal. Okay, that really doesn't exist. Centrifugal with an F, or centrifugal force, is actually a force that points away from the center of a circle. All right, this one is the one that we focus on because this is the force that keeps objects moving along that circle. If we're looking at centrifugal force, that's that force that really doesn't exist, but we think it does because we experience something. Like if we're in a car and somebody goes around a curve, okay, and we feel like we're being pulled toward the outside of the car, toward like the door. Okay, that's what we experience as centrifugal force, but that's really not what's going on there. As we're being pulled toward the door or something like that, that's just a direct result of our inertia Our inertia is keeping us in place, but the car is moving out from underneath us. All right, so two different things. What we really need to know is that centripetal, the word, means toward the center, and we've got both centripetal acceleration and centripetal force. And we already know that acceleration and force are directly related because of Newton's second law of motion. Well, guys, I hope this is helpful, and I hope you got this into your notes. As soon as you finish this, show this to me, and we will get started with our little lab. Okay? See you next time.